Alright, Jacob. So, your directions say that you need to graph each system of inequalities, name the coordinates of the vertices of the feasible region, and then find the maximum and minimum values of the given function for this region. All I get from that is blah, 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 blah. But I'll do my best to explain to you. So the first thing we're going to do is we're going to put these equations in a form that's going to make it easy for us to graph. And my favorite form is slope-intercept form. So that's going to be the form of y equals mx plus b, because it's really easy to graph from that form. So to put stuff into slope-intercept form, we're just going to solve for y. So I'm going to start with this first equation, the one that's in black, and I'm going to go through and I'm going to subtract 2x from both sides. And then I'm going to have 3y is greater than or equal to a negative 2x plus 6. And then I'm going to go through and divide everything by 3. And now I've got from my first equation, y is greater than or equal to negative 2/3 x plus 2. Alright? And then we go through and do this for the other equations. Let's see. Minus 3x, minus 3x, negative 2y is greater than or equal to a negative 3x minus 4, divide by negative 2, and always, always, always when you are dividing by a negative number or multiplying by a negative number with your inequalities, remember that your sign will flip. So I'm left with, over here for this equation, y is going to be less than or equal to, what is that, 3 halves x plus 2. Alright, and let's do our last one here, this green one. This one's nice and easy. We're going to solve for our y, so we're going to subtract 5x from both sides, and we're going to be left with y is equal to, whoops, my bad, y is less than or equal to, what, negative 5x plus 15. Crap, that might cause a problem for our graph. Okay, so these are our three inequalities that we're going to graph. So now let's take a look at a graph. Oh look, hey, here's a graph. That's helpful. And we've got our three equations over here. So I'm going to start with the black one. And I'm going to go to my y-intercept, which is a positive 2. I'm going to put a dot at positive 2, y equals positive 2. And then I'm going to use my slope. So I'm going to go down 2 over 3, because I have a negative 2. So I'm going to go down 1, down 2, and then over 3. 1, 2, 3. And I'm going to put a dot right there. And so that's my line for that equation. Should go something like that. And when you're doing these, it's very important to make sure that you're accurate with your lines, because it's going to make a difference when you go to see where all these things intersect. Alright, next one, let's look at the red one here. I'm going to go up 2 again, just like I did with the other one. Oh, shoot, you know what, let's talk about the shading. So we got to figure out where we're going to shade this thing. If I put in 0 for x and 0 for y, so I would have 0 for x and 0 for y. So we're going to say 0 for y, and then 0 for x gives us, this becomes 0 right here, so it gives us 2. And is 2 greater than or equal to 2? No, it's not. So that means that this one is going to be shaded that way. Okay, and that's just going to kind of help us keep that in mind. Alright, and since it can be equal to, you know that you have to go through and actually make this like a dotted line and all that crap, but whatever, I'm not going to worry about that right now. Alright, so I went ahead and graphed the rest of these using the same thing. I looked at my y-intercept for the red one, which was at 2, and then I used my slope. I went up 3 over 2, put a dot, and then kind of graphed my line. And then I plugged in the point 0, 0 to see where I should shade it. Now you'll notice that this region right here is where it should be shaded for all of them, right in there. So that's our possible solution area, right in there. And so the last part of your question was, oh crap, what did it say? Stupid freaking math. This sucks. Find the vertices of each region. So the vertices are just where our lines cross, so we're going to go through and look for those points. So we have one here, one right there, one right there, and one right there. So our first vertices over here is at 0, 2. Our next vertices up here is at, what is that? X is 2, Y is 5. So 2, 5. And this vertices over here, X is 3 and Y is 0. So those are your 3 vertices. Now what you're going to do is you're going to go through and look for your highest point and your lowest point and plug that in. And it looks like you just texted me. What'd you say? Find a video on YouTube if you're not already on the way. Oh. Well, I'm not on my way because I've got to do something tonight on Skype, but I am making this video for you. Hooray. Anyway, so take these highest values. So we would use, to figure out the function of x, so remember we had that f of x is, f of x, y is equal to x plus 3y. We would take our highest points and our lowest point. So highest point is 2, 5. So our x value is 2, our y value is 5. So we would have 2 plus 3 times 5, or 17. So this is our max value for f of x. And our min value for f of x, we would use this point. And we would plug in 3 for x, 0 for y, and we would get 3. And those would be your values. Do you see what I did there? I took the highest point, the lowest point, and plugged them into the function f of x, and then got a value. Hope this helps. I hope you kind of were able to follow along. I know I was kind of all over the place. Madison's in the bathtub yelling at me that she wants to get out and all this crap. Anyways, feel free to text me if you have any questions. Later.